Before we can start discussing Earth's history, we have to know how we divide that history up. And we're going to break it down starting with a fundamental concept called deep time. James Hutton, a Scottish geologist, developed the idea of deep time in the 18th century. This theory proposes that Earth is much older than religious texts suggest. According to Hutton, the slow, gradual processes that shape our planet, like soil erosion and mountain formation, have been happening for billions of years. Today, we know that the Earth is around 4.6 billion years old, a vast timeline that allows for major events like the shifting of continents and the evolution of species. One of those long-term processes is continental drift, the slow movement of Earth's continents over millions of years. It's hard to imagine, but the continents were once joined together in a massive supercontinent called Pangaea. Over time, tectonic forces caused the land masses to drift apart, shaping the world we live in today. To understand these shifts, we rely on the principle of uniformitarianism, developed by Charles Lyell. This idea tells us that the same geological processes we see today, like volcanic eruptions and erosions, have been operating in much the same way for millions of years. This is crucial because it means that the past is not as mysterious as we once thought. We just need to observe the Earth today to understand how it's always worked. Speaking of the past, let me introduce you to Mary Anning. She was a remarkable fossil hunter in the 19th century. Fossils are the mineralized remains or imprints of ancient organisms. They provide snapshots of life from millions of years ago and are essential for studying evolution and understanding how life has changed over time. Mary Anning's fossil finds helped provide physical evidence that life on Earth was vastly different in the past. She found some of our most famous fossils, like those from the Ichthyosaurus and the Plesiosaurus. Despite having little formal education, Mary Anning's discoveries challenged old beliefs about Earth history and the creatures that lived here, contributing to our modern understanding of evolution. When talking about fossils, you've got to understand geological time. You'll often see the terms BYA and KYA, which stand for billion years ago and 1,000 years ago, respectively. These terms help us pinpoint events on Earth's timeline, whether they occurred billions of years ago or just a few thousand. Geologists divide Earth's history into manageable chunks: eons, eras, periods, and epochs. Eons are the largest time units, lasting billions of years. They're divided into eras, which span millions to billions of years, and eras are divided into periods, which in turn are subdivided into epochs, which are the smallest unit of geologic time, usually spanning thousands or millions of years. For example, we're currently in the Cenozoic era, which began about 66 million years ago. More specifically, we're living in the Holocene epoch, which started around 12,000 years ago after the last ice age. However, some scientists believe that we've entered a new epoch, the Anthropocene. This term, Anthropocene, highlights the massive impact humans have had on the planet, from climate change to mass extinctions. While there's still debate about when exactly this epoch began, many argue that human activity has fundamentally altered the Earth in ways that rival natural forces. Understanding these terms like deep time, continental drift, fossils, and all the rest we've discussed helps us make sense of Earth's incredibly long history and our place within it. As we study the past, it's crucial to recognize the changes our planet have undergone and how we, as humans, are now shaping its future.